This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIMS and NEET. Now we'll see some problem based on the concept we have learned. First problem I picked from AIPMT 2010. A ball moving with velocity 2 meter per second collides head on with another stationary ball of double the mass. If the coefficient of restitution is 0.5, then their velocity after collision will be. So first I draw the figure pertaining to this problem, and this is our ball having mass m. It's moving with a velocity equal to 2 meter per second. It is given that we consider this velocity is equal to u1 and it is equal to u is equal to 2 meter per second. Again, the second body, it collides to a body having a mass equal to 2m as per the problem, and this body was stationary, so u2 is equal to 0. So this is the figure before collision, and after collision the m mass is moving with velocity v1 and 2m mass is moving with velocity v2. So this is the case of after collision. Now it is given that coefficient of restitution E is equal to 0.5 is equal to 1 by 2. Now we have to calculate the velocity after the collision. So first we will apply the law of conservation of linear momentum in case of collision. It is equal to initial momentum is equal to final momentum. Initial momentum is equal to momentum due to these two bodies before collision, and it is equal to m into 2, and the final momentum is equal to m into v1 plus 2m into v2. So from there we get equal to 2 is equal to v1 plus 2v2. So this is basically our equation 1. Now if you apply the formula of coefficient of restitution, then E is equal to velocity of separation divided by velocity of approach. So velocity of separation is equal to v2 minus v1 as per this figure, and velocity of approach is equal to u. So we get v2 minus v1 is equal by u is equal to 2 and it's equal to coefficient of restitution, which is equal to 0.5. So from there we get v2 minus v1 is equal to 1. So our second equation is that 1 is equal to v2 minus v1. So this is our equation 1 and 2. If we add these two equations, we get 3v1 v2 is equal to 3 and v2 is equal to 1. And similarly, in case of if we do 1 minus 2, if I subtract 2 from 1, then we get v2 is equal to, in fact we have to do 1 minus 2 into 2, then we get 2 v1 plus 2v1 plus v1 is equal to 2 minus 2, and from there we get 0. So v1 comes equal to 0. So basically we get v1 is equal to 0 and v2 is equal to 1 meter per second. So the velocity of these two bodies after collision is equal to 0 and 1 meter per second, and the answer will be 2. Now we will move to our next problem, and this problem says that ball 1 collides with another identical ball 2 head on at the rest. So for what value of coefficient of restitution E, the velocity of second ball becomes 2 times that of first ball after collision. So this problem is similar to the previous problem, and it says that another ball 2, it's an identical ball, so this ball is having mass m and first ball having mass m also. So ball 1 having mass m, it's moving with a velocity equal to, let's say it's moving with velocity equal to u. This ball 2, this is our ball 1, this is our ball 2. Ball 2 is in rest, so we keep its velocity equal to 0. And this is the case before collision. After collision, it's given that velocity of second ball becomes 2 times that of the first ball. So this is the first ball with velocity is equal to v, and the second ball with velocity is equal to 2v. So as per this problem, we have already drawn the figure that before collision the second ball was in rest, while after collision the second ball having the velocity equal to twice the velocity of first ball. You have to calculate the coefficient of restitution. So this type of problem, we have already derived the formula for this, for the identical ball, and if the second ball is in rest, then the velocity comes out to be, that is v1 is equal to 1 minus e by 2 into u, and v2 is equal to 1 plus e by 2 into u. It is given that v2 is equal to twice v1, and from there we get 1 plus e by 2 into u is equal to 2 1 minus e by 2 into u, and from there we get 1 minus e is equal to 2 minus 2e, and e is equal to, in fact, it's equal to 1 plus e. So basically we get 3e is equal to 1 and e is equal to 1 by 3. So e comes equal to 1 by 3, or the coefficient of restitution of the ball will be equal to 1 by 3. So this is the problem based on the formula we have derived. If you don't remember the formula, you just go through your basics, and basic is the first is the conservation of linear momentum. So pi is equal to pf, and from there we get initial momentum is equal to mu, final momentum is equal to mv plus 2mv, as the velocity of second ball after collision is equal to twice the velocity of first ball. So from there we get u is equal to v plus 2v. So this will be our first equation. 3v is equal to u, and again, as we know that for coefficient of restitution, in this case e is equal to velocity of separation minus divided by velocity of approach. So velocity of separation is v2 minus v1, velocity of approach is u. So v2 is equal to 2v minus v divided by u, and from there we get v by u, and as per this relationship 1, we can say that v by u is equal to 1 by 3. So coefficient of restitution comes equal to 1 by 3. So in this way we can calculate the coefficient of restitution. Now we move to our third problem. This is in fact a good problem. A ball strikes a horizontal floor at an angle theta is equal to 45 degree. The coefficient of restitution between the ball and the floor is equal to 1 by 2, the fraction of kinetic energy lost in collision. So basically you have to calculate the fraction of kinetic energy lost in case of inelastic collision. So we have already derived the formula for this also, however we may go through the basics. So I just draw the figure for this. This is our floor, and the ball strikes to this floor making an angle theta is equal to 45 degree. So ball is making an angle theta is equal to 45 degree. Afterwards it moves with some, making some angle. Suppose this is making now angle theta, and this is the path before collision, this is the path after collision, and you have to it is given that E is equal to 1 by 2. You have to calculate the fraction of kinetic energy lost. So let's assume that the initial velocity will be u. So u will be the velocity before collision. So the velocity before collision may be divided into two components. One is the component along the floor or in the horizontal direction, and other component is the velocity component which moves perpendicular to the floor. So basically this velocity which is moving perpendicular to the floor or normal to the floor will be suffered with a difference in velocity. Like if it is moving with a velocity v, then after collision it will rebound with a velocity equal to ev. I will just show it here. Suppose this ball moves with a velocity u, and after striking the ground it will return with some velocity v. So if the coefficient of restitution will be E, then E is the velocity of separation divided by velocity of approach. So E is equal to V minus 0 divided by U minus 0, as the floor is in rest. So from there we get V is equal to EU. So basically you have to, the normal component of velocity changes in case of collision. The tangential component remains the same. So we may write in this way that ux is equal to u cos 45 degree. And if you this figure, this is our v, then vx is equal to v cos theta. So the tangential component remains the same, so we may write that ux is equal to vx, and from there we may write u cos 45 degree is equal to v cos theta. So this is our first equation, or v cos theta is equal to u by square root 2. Now due to collision, the return velocity or the rebound velocity changes. So we may write that v sine theta, or basically uy is equal to u sine 45 degree, with which it is approaching, while it returned with a velocity equal to vy. So vy is equal to E into uy, as E is the coefficient of restitution. So we get E into u sine 45 degree, and it comes equal to u by 2 root 2. So v sine theta is equal to u divided by 2 root 2. So if this is our equation 1, this is our equation 2. If we use equation 1 and 2, we can get the final velocity. So final velocity v is equal to square root vx square plus vy square, and from there we get v is equal to u by root 2 square divide plus u by square root 2 square, and from there we get square root u square by 2 plus u square by 8. It comes equal to square root 5 by 8 u square. And the fraction of kinetic energy lost. So kinetic energy lost fraction is equal to final lost kinetic energy is equal to half mv square, in fact half m u square minus half mv square divided by half mu square. It's equal to 1 minus v square by u square, and it comes equal to 1 minus 5 by 8, that is equal to 3 by 8. So fraction of kinetic energy lost will be equal to 3 by 8, or the fraction of kinetic energy retained by the object or the ball will be 5 by 8. So this is the example of oblique inelastic collision. in case of oblique inelastic collision, you have to consider the velocity normal to the collision in order to change in the velocity. The velocity tangent to the second body will not be affected. So here also the tangential velocity remains the same, while the normal or the perpendicular velocity changed by a factor equal to e.